Hello friends, welcome back to the new video of Kilmer. So today we are going to discuss on the chapter periodic table, and that is a continuation part of the previous video. So the previous video on the periodic table link is given in the description below. You can go and watch it. First of all, I would like to thank you for 50 subscribers. So thank you for 50 subscribers and keep supporting to my channel and like the video and share it to your friends. So without delay, let us go into the video.
So friends, in the previous video actually I didn't give you more information about Henry Moseley. Actually it wasn't more, but the important thing was Henry Moseley, as I said you earlier, Henry Moseley gave the periodic table on the basis of atomic number. Remember that, okay? I'm sorry, atomic number, okay? So Henry Moseley gave the periodic table on the basis of atomic number. So what did he say? Atomic number is equal to number of electrons in the energy shell of an atom. So I'll say you what is a shell, okay? Actually, just a minute. I thought of saying it here. Okay, whatever. So when you take a particular atom like sodium, so if you take sodium, what is its atomic number? I said you in the previous video, you need to by heart all the 20 atomic numbers and mass numbers of elements in the periodic table. 20. The first 20 are very important. That is enough for your board exam. You need to by heart all the 20 elements, atomic number, mass number, okay? So atomic number of sodium is 11. I'm sorry, okay, it's 11. Okay, so when you in the arrangement of atomic numbers, you need to take shells, okay? Suppose if you take sodium, so if you take sodium element, and then you need to draw this shells. First shell, second shell, third shell, like that. There will be n number of shells, okay? So here it starts from when they ask you what is the first shell name, what is the name of first shell, so it is K shell, okay? K, and this is L, M, N, okay, and this is O. It goes on like that. And don't ask what is the shell after Z, okay? We even it is not there in your syllabus, okay? So when sodium has a many number of shells, in every element has n number of shells, okay? So when it comes to sodium, it has 11 number of electrons. So in order to place these electrons, the first shell, K shell, the first shell, it contains only 2 electrons. If you if you want that shell to have more electrons, it doesn't exist, okay? What happened was the atom will blast, okay? So only 2 electrons you can keep in the first shell. When it comes to L, you can keep only 8 electrons, and M, and when it is M, I'm sorry, just a minute. When it is M, you can keep 8 electrons in M also. So I guess up to here it is enough for sodium atom. Okay, so now when you take this sodium atom, the first shell consists of 2 electrons. Okay, 2. Just a minute, another color, we'll change the color. Okay, first shell consists of 2. So 11 minus 2, how much you have? 9. The second shell has 8. 11 minus 10, still you have one more. So in the third shell it will contain 1 electron. I guess you understood this one. So let us do with another element. Just a minute. Okay, so let us take another element. For suppose if you take aluminium. So the atomic number of aluminium is 13. Okay, so how to write this? 2 8 3. Did you understand how to write the atomic number? So now we will take another element. For suppose let us take calcium. So if you take calcium, now what is atomic number of calcium? So calcium's atomic number was 20. So now if you write the shells, number of electrons in number of shells, so 2, 8, see here 20 is there, so still 10 more electrons were there. So 8, then 2. Did you understand how to write it? I guess I didn't say you about number of electrons in N shell. N shell will contain 18 electrons. Okay, so K has 2 electrons, L has 8 electrons, and M has 8 electrons, and then N has 18 electrons. Remember this. Up to here it is enough. Okay, up to here this is enough for you. Now, so what did Henry Moseley say? Atomic number is equal to the number of electrons in energy shells of an atom. So what did Henry Moseley say? He said atomic number is equal to number of electrons in the energy shell of an atom. So what we were discussing was sodium. Its atomic number is 11. So how did we write the shells here? I'll show you. Wait. Here we wrote what we said was sodium has 11, that means it has 11 electrons. So we need to classify these 11 electrons in the atomic orbits. So we classified the electrons as 2, 8 and 1. So Henry Moseley was the first one to say that atomic number is equal to the number of electrons present. Remember, first point was atomic number is equal to number of electrons. Okay, remember this point. So physical and chemical properties of element depend on number of electrons in their arrangement. So the previous scientists, whom we have Dobrinier, Newland, Mendeleev, so all these three people, they what they said was physical and chemical properties. I said you that one. Physical and chemical properties depend on atomic masses. So these three scientists, the previous scientists, they said physical and previous scientists. The previous scientists, they said physical and chemical properties depend on atomic mass. Remember this, atomic mass. But Henry Moseley said physical and chemical properties depends on atomic number. You need to remember this. Actually, mostly they might ask you this one. The physical and chemical properties depend on periodic function of their atomic mass. You need to remember that. Who said that? Like they might ask you in your board exam that who said about atomic number, or who said about atomic mass, like that they might ask you in your examinations. So you need to remember atomic number and atomic mass. So moving on to the next topic, we have periodicity. So as per your textbook definition, the properties that reappear at regular intervals or in which there is gradual variation at regular intervals are called periodic properties, and the phenomenon is known as periodicity of elements. So what does this mean? Okay, let us study about the periodicity definition. Okay, so basically when you take the periodic table, see, when you take this periodic table, what happened was, when you look here, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, when you look at this particular group, so what is this group name? Do you remember? In previous class I said you this group name is alkali metals. Okay, so this particular alkali metals, when you take these alkali metals, when you see the atomic number, of these alkali metals, so lithium has 1, sodium has 11, potassium has 19, rubidium has 37, cesium has 55, and then francium has 87. So lithium has 3. Lithium has 3. I wrote it here, I wrote as 1, it has 3. Okay, so when you look at these atomic numbers, see it is increasing. Here it is 3, and then 11, 19, 37, 55, 87. So the atomic number is increasing. Similarly, the mass number also increases. So when you by heart these mass numbers and atomic numbers of first 20 elements, I said only 20 elements, you will understand. Okay, the atomic number increases and the mass number also increases. So due to this increase in atomic number and mass number across the period and down the group, there are some some properties also will change. If you take properties like number of shells, and you take number of shells, so on basis of across the period, when you take across the period, the number of shells remains same. I'll explain you that one detailedly. So similarly, when you take the number of shells down the group, the number of shells increases. When you take across the period, that remains same. So similarly, when you take valency across the period, the valency at starting it increases and then it decreases. When you take down the group, the valency remains same. So there are many trends like that varies because of the atomic numbers and mass number. Sorry, because of atomic number. So these regular trends that vary are known as periodic properties, and that phenomenon is known as periodicity of elements. I guess you understood what is periodicity. Okay. So when you take what is the cause of periodicity? So this is a important thing. Even the definition of periodicity is also important. So as per your textbook, it was given the cause of periodicity is the recurrence of similar electronic configuration, that is having the same number of electrons in the outermost orbit. Okay, what is an outermost orbit? So when you take sodium, so it has 2, 8, 1. So I am drawing its structure. Okay, wait. So this is first orbit, this is second, this is third orbit. So this is third orbit. So just a minute. Yeah, okay. Sodium. So it in the first orbit it has 2 electrons. Okay. In the second orbit it has 8 electrons. So in the last orbit it has only 1 electron. Last orbit in the sense, in the orbit it has in the orbit where the electron exists. Okay, so this is known as the outermost orbit. So this last orbit, this last thing in which there is only 1 electron, so this orbit is known as, this particular orbit is known as outermost orbit. Okay, so what is the cause of periodicity? Recurrence of similar electronic configuration. So when you take wait, I'll show you the periodic table, you will understand that. Here is the periodic table. Okay. When you take this alkali metals group, so if you draw the structure, if you draw the orbit diagram for all these alkali metals, then in every element, in lithium or sodium or potassium or rubidium or cesium or francium, in all these elements, in the outermost orbit you will have only 1 electron. Okay, similarly if you take this alkali earth metals, if you take this alkali earth metals, this beryllium, magnesium, calcium, strontium, barium, radium, if you take this group, if you draw the orbit diagram, in the outermost orbit you will have 2 electrons. When you take this, and then when you take this third boron family, 13th group, okay, when you take this one, you will have 3 electrons. When you take carbon family, you will have 4. Nitrogen family, you will have 5. And oxygen family, you will have 6. Halogens 7. And then what are these? Noble elements. These noble elements, you will have 8 electrons. That means it is completely filled orbital. Okay, so it doesn't what is a complete and incomplete orbital? I'll explain you. Wait. So if you take neon, which is a noble element, if you take neon and you draw its structure, I mean this atom orbital diagram, neon. So wait, I just forgot to say you about this atomic number. Neon's atomic number is 10. It is just before sodium, so it has 10. Atomic number is 10. So how to write the electrons, number of electrons in the orbitals? 2. 2, 8. Okay, did you understand? So here 1 electron, here 1 electron. So here 1 2 3 4 5 6 7 8. What did I say? I said the first orbit has 2 electrons, the second orbit has 8 electrons. So here 8 complete electrons are there. I mean this orbit has complete electrons, so that means this is a complete orbit. Okay, complete. So what is an incomplete orbit? When you take your sodium, here it has only 1 electron. Okay, when you take sodium, it has only 1 sodium. When you take sodium, it has 2, 8, 1. It has here 2 electrons and then here 8 electrons, and then here only 1 electron. So still it requires how many electrons to complete this orbit? It requires 7 electrons to complete. So that's why this is an incomplete. Okay, incomplete orbit. Okay, so I guess you understood about what is periodicity and what is the cause of periodicity. There is some more description about periodicity in your textbook. In a particular group, electrons in the outermost orbit remain same. That is, electronic configuration is similar. So outermost orbit, I said you, in a particular group, it is halogens or boron family or nitrogen family. When you take that particular family or particular group, the electrons in the outermost orbit is same. Okay, so what does that imply? Chemical properties depends on number of electrons in the outermost orbit. Chemical properties depends on number of electrons. That means chemical properties depend on atomic number. Thus, elements of same group have similar properties. So if you take alkali metals, those all metals, alkali metals have similar properties. If you take alkali earth metals, those have similar properties. These both properties doesn't match. Of course some match, but they are not exact. Okay, so moving on to the next topic, it is number of shells. Okay, number of shells on moving down the group across the period. Just a minute, I'll explain you. Okay, number of shells. So when you take number of shells, not only number of shells, basically I thought of explain basically this thing you remember. From now on I will explain you about trends. Okay, in every trend, in each and every trend, you need to note the thing. What is that? I will explain you first down the group. Okay,